Okay, so a flush in poker is having all the same suit of cards in your poker hand. So there's 13 of each suit, 52 cards total. What is the probability that a player is dealt 5 cards resulting in a flush that is not the suit of hearts or clubs? Okay. So there's 2 suits that we're talking about, okay? So it's not the suit of hearts of clubs. That means it's either the diamonds or the spades. So there's 2 choose 1 different ways of choosing those suits. And then after we've picked a suit to get a flush, then we need to multiply it by the number of different ways that we can get a what do they call it? I don't play a lot of cards. They call it a flush in poker. There's 13 cards of each type. Okay, that's why they put 13 down here. Choose 5. Because this first part represents, hey, this is the number of ways of getting the 2 suits that they said meet this condition. There's 2 suits. Choose one of them. And then once you've chosen the suit, there's 13 cards in that suit, and we need to choose 5 of them to get a flush. So this represents the number of ways you can get a flush if you're only dealing with one type of suit. There's a number of different ways of choosing the suits that they're talking about. So the bottom part of the formula is always the total, okay? Because when you're trying to calculate a probability, it's the amount you're interested in divided by the total. There's 52 cards we're choosing from, and we need to only pick 5 for our hand. So that's how this problem got to that solution. Let me see if I can find another one that we can work on together here. Oh, there it is. I think I just did a video for that one. Let's do the pediatrician one here. So Marianne is a pediatrician that has the following appointments today: 6 vaccinations, 3 wellness checks, and 5 ill children. Marianne randomly selects a file from one of the appointments. What's the probability that Marianne selects a vaccination? So probability is the amount we're interested in divided by the total. Okay, the amount of events that we're interested in divided by the total. So if they're picking from the file of today, there's 6 plus 3 makes 9 plus 5 makes, there's 14 possibilities to choose from. The probability that it's a vaccination, there are 6 that we're interested in. There's 6 vaccinations divided by the total, okay? And then when you simplify this, that's 3 over 7. Okay, let's see what else. I did that one today. I'll upload that in just a second. I think I might have done this one today. No, I haven't done this one. Okay. Okay. Company sends 15 representatives to an industry conference, 10 women, 5 men. Only 8 representatives will be given the chance to make the presentations. So just remember, a probability is the amount you're interested in divided by the total, okay? So down here on bottom, the total, oops. What's the question asking is for? Eight are going to be, total way of choosing 8 representatives goes on bottom, okay? Out of 15 total. And up top is the total number of ways of choosing. It says, what is the probability that all the representatives that make the presentations will be choosing 8 women? We want to find out the number of ways of choosing 8 women divided by the total number of ways of choosing 8 representatives. Okay, so there's 10 women, and we want to be able to find out, we want to choose 8 of them. The order doesn't matter. So 10 choose 8. That's the number of different ways of picking 8 women out of the 10. And the probability is the amount you're interested in. So this is the number of women divided by the total, which is the number of different ways, men and women, we could choose. There's 15 people. We're choosing 8 of them. So that's why they have it reversed. Okay. Oops. Where is it? Right here. 15 choose 8 on bottom. Okay. So just make sure the bottom's always bigger when you're calculating a probability. I think I got time for one more before my battery dies. How many different groups of 6 letters can be made from the word universal? So this is a permutation problem because with words, the order the letters come in, it matters, right? The order matters. So that's why we say it's a permutation problem, which you did. Okay, that's good. Solving the problem, so the order will matter. Good, that looks good. What's the second part? Oh, it's saying it's wrong. Okay, hold on. Different groups of 6 letters can be made from the word universal. Oh, okay. So 1, 2, 3, 4, 5, 6. How many different groups of 6 letters? So that's I read it wrong too. This one's saying how many different groups of 6 letters can be made. They're not saying how many different words, which is what I thought and what you might have been thinking too. Okay. It's saying how many different groups of letters can be made. Okay. So for a letter group to be different, it can't have any repeating, but the order doesn't matter. You know, U N I V E R is the same thing as R E V I N U. It's just a confusing question. Okay, they're saying that that they're making groups, not words. These two things are equal to one another. If you rearrange the letters, it's talking about having unique letters in the group. So that's why they're saying it's a combination. The order doesn't matter. Okay, definitely tricky on that one. I fell for the trick too. You'd think they're talking about making words, but they're saying how many different groups of letters. Can you cut out the letters, put them in a hat? Not making words out of them. How many different unique groups of those letters can you make?